Anyone? A difference quotient?
F of x plus h minus f of x over h.
Excellent. Thank you very much. So again, this is fine, this is fine, this is the problem. So we have to work on that. But because this is not a quadratic function, it's a rational function, we can write it out already. So can anyone give us that function, and then I'll copy x minus 1 over x plus 3 and h in the denominator. Okay? So can anyone give us this function evaluated at x plus h? Can anyone say anything? What do you think? Anyone? Just give it a shot. Do we have any difficulties evaluating this? Anyone? What do you think? What do you think we have to write for f of x plus h given this function? How will you evaluate? Sorry. Say it again.
X plus h minus 1 over x plus h plus 3.
Thank you very much. X plus h minus 1 over x plus h plus 3. Well done. If you have questions, don't let me move on. Okay. Next step is to continue from here. So the difference quotient. And this is my page 5. Difference quotient. H, or h over 1. The next step is to find the least common denominator. Can anyone tell us what is the least common denominator so we can subtract them? We can subtract or add fractions if they don't have the same denominator. So we have to find the least common denominator. What would be the least common denominator of that, of these two? What do you think? Do they have anything in...
1 over 3.
I'm sorry?
Negative 1 over 3.
The least common denominator. We have to find the least common denominator. In order to subtract them, we need the LCD. So for example, if I want to perform the operation 1/2 minus 1/3, what would be the least common denominator?
X plus 3.
No. So let's do this numerical example. 1 second. So when I want to subtract these two, what would be the LCD?
6.
6. Very good. 2 was multiplied by what?
3.
By what? To get 6.
3.
3. If I multiply the denominator by 3, I have to multiply the numerator by 3. 3 was multiplied by what to get 6? 2. So then the numerator has to be multiplied as well. So 3 times 1 is 3, minus 2 times 1 is 2, and that's how we get 1 over 6. Same idea here. This and this have nothing in common. Nothing. Like 2 and 3. 2 and 3 have nothing in common. The same thing, x plus h plus 3 and x plus 3, they do not have anything in common. So then what will be the least common denominator? Give it a shot.
Is it x plus h plus 6?
So did I say 2 plus 3 and I got 5? I can never add or subtract denominator.
S plus the LCD will be x plus 3 total, and then multiply with the s plus 3.
Very good. This is correct. It's the product of the two, exactly how we determine the product of these two to get 6. Because they have nothing in common. And like before, this denominator is here, like when we subtracted these two, I asked you 2 times what is 6? The same thing here, same question. This times what is this? Well, I have to multiply it by x plus 3. This times what is this? Well, I have to multiply the numerator by x plus h plus 3. These rational functions are not very friendly. They require a lot of work. So now I have to distribute x to these 3 terms and 3 to these 3 terms. So x times x squared, x times h, plus xh, x times negative 1, negative x. 3 now times x, plus 3x. 3 times h, plus 3h. 3 times negative 1, negative 3. All this, it's just this product. Now I reach the minus. Negative x times x, negative x squared. Negative x times h, negative xh. Negative x times 3, negative 3x. Finally, negative 1 times negative 1 is positive 1 distributed to x plus h plus 3. I just copy x plus h plus 3. Before we continue, what did we say? For any difference quotient, 2 things have to happen. So at this point, what do I expect to happen? If it doesn't, I have to go back to the drawing board. I have an error somewhere. So what has to happen first? Say it again.
The numerator cross out.
All terms without h. Maybe some terms with h too will go away, but that's a bonus. I don't care for that. It's fine. It's an extra. But all terms without h must go away. Positive x squared with negative x squared. Negative x with positive x. Positive 3x with negative 3x. Positive 3 with negative 3. Positive 3 with negative 3. That's nice. Positive xh with negative xh. So we have left a 3h and an h here. There is nothing else left. So I continue.
No, I think they still have the positive 3x instead of the negative 3x.
Positive 3x with negative 3x. Negative x with positive x. I'm not sure what you're saying. Can you say it again?
Let me see if I can do it.
Positive 3x with negative 3x. Is that what you're talking about? It's okay. Even if it's no error, I would like to go back and double check. Did you find your mistake?
Oh, that should be good. Should be fine. Sorry.
That's okay. You may see something I don't, so I will always stop and go back and double check. I don't mind. Do you want me to multiply again and make sure everything is okay?
Yes, please.
Sure.
Second place, please.
Yes. So x times x is x squared. X times h is xh. X times negative 1 is negative x. 3 times x is 3x. 3 times h is 3h. 3 times negative 1 is negative 3. So this is the first part. Now negative x times x is negative x squared. Negative x times h is negative xh. Negative x times 3 is negative 3x. But now I have minus and minus, and that changes into plus. 1 times x is positive x. 1 times h is positive h. 1 times 3 is positive 3. So far, so good? So, again, x squared with negative x squared. Negative x with positive x. Positive 3x with negative 3x. Negative 3 with positive 3. Positive xh with negative xh. So what we have left is 3h plus h, which is 4h. Is that okay? Are we okay now? Are we okay? Yes? Okay, so x plus 3, x plus h plus 3, multiplied by 1 over h. And this is when h goes away. That's why I recommend those steps. I accept other methods, of course, but I think that that is the safest route. This is the difference quotient for that rational function. Okay, I would like to look at piecewise defined functions. Any questions for me, please? Any questions? Anyone? Any questions?
How did you get times 1 over h?
Very good. Awesome. So I have a fraction now here that is 4h over this, and I'm dividing it by h over 1. So I have to flip. So the numerator is here, and when I divide by h over 1, I have to multiply by 1 over h. So that's how we divide two fractions. So if I have at the top a over b, and the denominator is c over d, I copy a over b and multiply by d over c. That's why I put it from the beginning as a fraction as h over 1, which is the same with h. So you can see why it becomes 1 over h. So this is division of fractions. Copy the top and multiply by the denominator. It's actually the multiplicative inverse of the denominator. Is that okay?
Yeah.
Perfect. Moving on then. Other questions for me? Anything? Okay, I would like to talk about piecewise defined functions. And their graphs. So I'm looking at problem 68 on page 23. You may remember or you may not remember how a piecewise defined function looks like, but it's defined in different pieces, not just one. It has more than one piece. Well, it happens that this one has 3. X squared for x less than 0, negative 3 for x equal to 0, x minus 3 for x greater than 0. We're asked to graph this function. Every time we are asked to graph a function, what is our first thought? What do we have to determine first? What is the very first thing we need to determine?
The intercepts.
Close. Even before that. Absolutely. Yes. If it has x and y intercepts, we should always look for them. Absolutely. But even before then. Every time we're asked to graph any function, we have to find the domain first. This is our first priority. The rest can be done in any order you prefer, but the first thing has to be the domain. So I'm looking at x less than 0, and I know that this is the interval negative infinity 0. I'm looking at this and I know that this is the same with the interval 0 to infinity. If there is something you don't remember, please don't be shy and tell me I don't remember this, and I will explain. You're helping me and your colleagues and yourself. Okay, so now I'm looking at the domain, and I'll say, okay, this function has everything to the left of 0, has 0, and everything to the right of 0, so obviously it must be all real numbers. So then I get my domain up here, and I realize that this function has 3 pieces, and it has a very important key element, or x value, which is 0. 0 will always be in the table, even if it's a key element or not. Also, I see that at 0, this function is -3, but also has a parenthesis to the left of 0 and a parenthesis to the right of 0. On this territory, you may say this is an overkill. I would agree, but I like to have it in front of me. Sometimes the pieces are not presented in the correct order, so you have to be careful. And on this side, it's x minus 3. This is a quadratic function, and this is a linear function. Linear, quadratic. So I don't forget how to graph. Now, 0 is not here, 0 is not here, and 0 is not here. So, however, I'm going to plug in 0 and put the number right here inside the parenthesis. When I plug in 0, I get 0. When I plug in 0 here, although I should not, I put -3 inside of parenthesis. On the left-hand side, I will find at least one other value, let's say -1. I plug in -1 and I get 1. On the other side, I'm going to plug in 3 because as one of you just said, x and y intercepts, of course. 3 minus 3 is 0. I'm ready to graph the piecewise defined function. So I will graph in 3 different colors so you understand that there are 3 different pieces here. So -1 for x, 1 for y, full point, 0, 0, open point, because this point is not included because of the parenthesis, open point. And I'm graphing a quadratic function. It opens up. I missed it a little bit. It opens up. It stops here. And that's the left-hand side. 0, -3 is this full point. And now on the other side, I'll use a different color, let's say green. So 0, -3 is the same point. It would have been an open point, but this is already full, so I start here. And 3, 0, this is a straight line because it's a linear function. And this is the graph of f of x. I'm going to ask you now to find the range for us. What is the range of this function? Can anyone give us the range of this function? So from -3 to infinity, right? -3 to infinity. Any questions on how to graph a piecewise defined function? And tell me if you would like to work on another, or is this good enough? Would we like to see another, or is this okay?